हरिः कर्ता।
Brilliant, fantastic. So we have seen a scatter plot, pair plot, parallel coordinate plot, and even correlation matrix, correlation coefficient matrix to analyze the feature relationship, to understand the relationship between the features. But there is a common phrase in statistics that correlation does not imply causation. Okay, so correlation doesn't mean it's a causation. So how do you find out the causation? How do you statistically tell that this is causation, not just mere chance? How do you tell that? So for that, what we require is statistical tests, a feature relationship analysis under that statistical tests. So what all statistical tests we use? So statistical significance test or statistical procedures. So like G test, T test, ANOVA, chi2 test, F test, chi2 test are commonly used in statistics. So it's more accurate to classify some of them as a specific types of statistical procedures or techniques rather than tests. So basically these are the statistical significance tests which can be used to test the statistical significance of the relationship between the features or relationship between the dependent and the independent variables. So just analyzing the relationship between the variables is not enough to understand whether is it causality or just mere chance. You need to do a statistical significance test, or we can also say it as a statistical procedures. You need to follow statistical procedures to decide the statistical significance of the respective relationship of the features. So what all tests that we widely use to do this? So that's what we are gonna discuss in this slide. So the first one is G test, and the most famous one. So G test is a statistical procedure used to test hypotheses about population mean when the population standard deviation is known. So it involves comparing a sample mean to a known population mean and calculating a test statistic based on the standard normal distribution. So the G test typically used for large sample sizes. So then we have a T test. So T test is a statistical procedure, or T test is a statistical significance test, is used to test hypotheses about population means when the population standard deviation is unknown or when the sample size is small. So it involves comparing the means of two independent samples. So that's why independent samples T test, or the mean of one sample to a known value. Of course, it's called one sample T test. So the test statistic follows a T distribution. And the third one we have is ANOVA, analysis of variance. ANOVA, analysis of variance. ANOVA is a statistical procedure used to compare the means of two or more groups. So it assesses the variability between groups and within groups to determine if there are significant differences among the means. So ANOVA provides an F-test statistic to evaluate the significance of the observed differences. Then what we have here is part of ANOVA F-test. So F-test is a statistical test used in analysis of variance ANOVA to determine if there are significant differences among the means of two or more groups. So it compares the variability between groups with the variability within groups. So the test provides an F statistic and a p-value allowing for conclusions about significance of the observed differences among groups. So then we have a chi-square test. A chi-square test is a statistical test used to assess the independence or association between two categorical variables. So it involves comparing the observed frequencies in a contingency table to the expected frequency. So the test statistic follows a chi-square distribution. Then the last one, a chi2 test. chi2 test, also known as a chi2 honest significance difference test, HSD, is a post hoc test performed after conducting an ANOVA to determine pairwise differences between group means. It helps identify which specific group means are significantly different from each other while controlling for the family-wise error rate. So while the exact categorization of these techniques may vary, but these tests, so we might have more tests under this. So these statistical tests plays important roles in hypothesis testing, comparing groups or means or assessing the associations and identifying significance differences. So they provide a rigorous statistical evidence to support or reject hypothesis and draw meaningful conclusions from the data analysis. And that's what the benefit and the power of statistical significance test. So basically, to sum it up, to put it in a nutshell, in exploratory data analysis, you will be exploring the relationships between various features and the relationship between feature and a target and a feature and an outcome. But how do you confirm that relation is causality? How do you confirm that? How can you tell that it's not confounding? That can only be told by statistical significance test. So that's the reason we will be deep diving into the statistical significance tests, various statistical significance tests under feature engineering, because under feature engineering the main agenda or main purpose of feature engineering is to select the features or extract the features or convert the variable into features. And fundamentally, selecting the feature belongs to, it comes under the feature engineering. So that is the reason when you conform the relation, because of when you conform that the relation is not mere chance, it's because of causality, then you are telling that this is a feature. When you confirm that The relation between the independent and dependent variable is not mere chance, it's because of causality. You're confirming that this is a target variable and this is your feature. So to confirm that, we require a statistical significance test. When you confirm that that variable will become a feature, hence we call it as a feature engineering or feature selection under feature engineering. So that is the reason I will be deep diving into the G test, T test, F test, chi-square test and q-kis test in detail under feature engineering. Just brace yourself for the more action.